Weird. So one of the things we wanted to intro here was the troubleshooting data workflows, the Notable and Dagster. And we really want to walk through what, kind of a live example and be able to guide some folks in how this can be achieved and follow along on some of the blog posts and the content here that we're walking through. So from the beginning, I want to talk a little bit about the pain points you can find in doing kind of data pipeline work. And one of the really big pain points when you're doing ETL and especially scheduled ETL is when you have errors to troubleshoot, this feedback loop between the error and the data engineer can get very slow and long. Like you can have things like that data pipeline step in the middle might take hours or even days to fully execute. So when you get errors, you oftentimes have to get creative about how you reproduce the minimum copy of what happened in order to fix the problem. To kind of talk into that, this creates really fragile chains of ownership that's owned by multiple teams. So let's take this as a real example of something, I debugged in the past for people and helped them walk through that involve like 3 different teams, which was, you have a fragile chain of tools that are owned by many teams. You have something goes wrong in your ETL. To track it down, well, the problem is, your Tableau report isn't refreshing. Okay, you go back and look at my SQL extract query. You look at that, and that might be, something where, okay, where's that coming from? And you look, and well, it's actually just pulling from a copy of data that came from Druid. You go to Druid, and Druid will just pull, ultimately it was sourced from data that's populated by Spark. And you keep going back and back and back all the way back to the event. You have to kind of trace this lineage of tools, and stitching together with various libraries and tools like this is really difficult. And not all the technology choices are ubiquitous to the user base that might be looking at them. So part of this is to kind of walk through when you use notebooks, you can actually capture the intent of what was executed. You can have, the collection of queries. And on top of that, when we go through the demo here, we'll show you once you combine Notable in, you can actually land in a live session that has the real context in memory for you to play with and manipulate. And this gives a lot better visibility into that tool chain you're using. It allows you to share with your constituents that are using that content to manipulate and edit it to their own needs, and it reduces the friction for having to have lots of data engineers in the middle for many types of data recovery and problems. And we'll kind of walk through a few examples here as we go. And what we're using today, just to kind of outline, we're using Gitpod. Otherwise, you can use a local virtual environment if you're comfortable with that. Gitpod's a great place to start for if you want to get a clean slate that's going to be consistent. We're using Dagster, which is the primary product here built by Elementl. And then we're using some other open source libraries, Papermill, and then some extensions that allow Papermill to talk to Notable. Papermill is the headless notebook executor that runs in Python. So it's a way to run notebooks programmatically. And we have a nice little plugin that just slots right into that technology called Origami. So when we shorten that feedback loop of errors that you can kind of run into, one of the things that you oftentimes need to do is go inspect the most recent, like what are you compiled and what are you executing at the end of a particular pipeline. And in that, oftentimes what happens is you'll get an error, and the error most of the time is a trivial error. It's in something like a column got renamed, or there's a new row in the data that's causing a problem. Or something along those lines. And to be able to live troubleshoot this on the actual data that you had pulled in and collected locally in order to evaluate what's different if the error message doesn't tell you immediately, it can be really valuable. And really shortening this feedback loop saves you a ton of time, saves you a ton of resources over time. We can say this like with confidence that in places where we built internal tools for doing these types of things, not even to this extent of even just having visibility of the rerun, let alone have a live session, it saved a ton of time. So let's talk a little bit about how we're going to achieve this and what the relationship is between these tools. We talked about Papermill, we talked about Dagster, and we've talked a little bit about, haven't talked a whole bunch about Notable yet. So for Dagster, You might be familiar with that as the scheduler DAG. It has a concept of asset resolution, where it's going to go find and build you assets based on definitions you provided in order to accumulate workflow. Noteable is a notebook platform that really provides a great enhanced experience over what you would typically get in open source Jupyter. It's based on Jupyter under the hood, and it runs through and does a bunch of quality of life improvements, as well as a lot of features that are well and beyond the scope of a notebook into the scope of data engineering needs and data analytics needs on the UI side. It's a really great platform for turning your exploratory work into production work and really kind of working through a lot of the issues that you would have in purely running the open source offerings in notebook space. And here, Papermill in the middle is going to be doing the translation of the Dagster parameters that it's providing. It's going to be putting those against the notebook version and giving you an immutable copy of a notebook run that is the materialization result of the asset. And then in failure, we'll have a window of time to go log in and play with that before it will automatically shut down the live context that has the error. So the workshop here, we're going to productionize a Jupyter Notebook that analyzes iris data. So we're going to start with just the basic example, use a Jupyter Notebook and see how that would work in Dexter. We're going to do some intro to the data pipelines that are used, particularly with task-based data access, asset-focused. And then we're going to do data pipelines in Dagster and the APIs and concepts around there. So I think from here, I'm going to hand off to Jamie.
Okay, great. So yeah, like Matt said, we're just going to start off talking kind of a bit of an overview of what data pipelines are, and we'll go through kind of like the process of designing the data pipeline that we're eventually going to be like implementing in the more like hands-on workshop portion of this. So just like starting off in like just kind of like a broad sense, let's just like talk about like what a data pipeline is. So a data pipeline is just a kind of like series of computations that result in some deliverables or data assets. And a data asset can be a lot of things. It could be a table in a database, an ML model, some kind of report, or lots of other things. And today, kind of the main one that we're going to be working with is a Jupyter Notebook. So a really classic example of a data pipeline is the ETL pipeline. And the like first step of this pipeline is that we're going to like fetch data from an external source. And then we might need to do some transformation on the data to clean it up or join data sets together, or like whatever we may need to do to get our data into kind of like a usable form. And then we need to store that data in a data warehouse. So today, like the workshop, basically what we're going to be doing is we're going to be analyzing sort of the canonical iris data set within a Jupyter Notebook. And so we want to make the process of doing that analysis and running the Jupyter Notebook part of our data pipeline. So we're going to start by sort of like in this design process, like replacing the steps of this template ETL pipeline with the steps we'll need to complete to kind of do our iris analysis and make that a self-contained like data pipeline. So the first thing we'll need to do is actually like fetch the iris data set. And we may do that with a tool like Airbyte that allows you to kind of ingest data easily without writing a bunch of custom API calls. And we're going to kind of take a little bit of liberties here because the canonical iris data set like doesn't really change. But to make this sort of example pipeline feel more like a real world example, we're just going to kind of pretend for a little bit that there's like a group of scientists that are consistently publishing new data about different species of flowers to a public database. And we kind of always want to be doing our iris analysis on the latest data. So at the start of our pipeline, we're going to be like refetching the data from this database. And then once we have the data, we want to like kind of transform it or clean it up. All of this like data that we've received from the flowers database into the data we want to analyze. And for this step, we might use some kind of specific data transformation tool like dbt. And the last step stays the same. We load our data into a data warehouse, and let's say we're using Snowflake. So the next thing we need to do for this is actually add our Jupyter Notebook into this pipeline. So let's add a step at the very end that fetches the data from Snowflake and executes the Jupyter Notebook. And this Jupyter Notebook is going to actually do our analysis of the iris data. So through this kind of like initial design of our data pipeline, I've kind of mentioned like a couple of different tools like Airbyte and DBT. And if you aren't like familiar with some or all of them, that's completely fine. We aren't actually going to be using them in the workshop, and you don't really need to understand like how they work to understand like the broader concepts we're going to be talking about today. I just have them in here so that if you are familiar with these tools or you do work with them like on a daily basis, you can see the parallels between this data pipeline we're working right now, or we're designing right now, and ones you may work with. So at this point, we've kind of designed our first pass at this data pipeline. We know exactly what tasks we need to execute, and we have a good idea where source data is and where data ends up. And so because kind of the main object we've modeled in this data pipeline is the task we're going to execute, we'll just kind of give this a name of a task-focused data pipeline. So let's take a step back and think about what might happen once this pipeline is up and running. So pretty soon we might get a request to analyze daffodils too. So we'll add some more code to the step that fetches data from the flower database to also get the daffodil data set. And we'll update the remaining tasks to handle this data as well, and we'll end up with a new table in our Snowflake database. But then, maybe we'll get a request to analyze roses, and we'll repeat the same process. So you'll notice that even though the tasks have become responsible for handling more data, we don't really have a good way to represent that in the individual tasks in our data pipeline in this like visual we see here. And if we want to understand what data exists, for example, after the ingestion step, we actually have to like dive into the definition of that task to like figure that out. And because like each of these tasks in our pipeline are responsible for more data, the bugs in them are going to become harder to track down. So for example, if our DBT transformation fails, we don't immediately know if it's because there's like maybe an issue with our DBT models, or maybe there's an issue with the raw data we're getting in. And if it is the raw data, we may have to investigate each data set individually to find the one that's causing the problem. So how can we kind of fix these issues? So let's start by just like taking a closer look at our pipeline, and we'll see that there's kind of more to it than just these tasks that we're executing. To kind of look at it a bit closer, each of these tasks produces their own data assets. So our task to fetch the flower data from the flower database produces a table of data for each species of flower. And the data we're storing in Snowflake is exactly the transformed data from our DBT tasks. And finally, the step to execute the Jupyter Notebook produces an executed notebook file. And that executed notebook file is actually what we're going to be like sharing around with our coworkers. So these data sets and the Jupyter Notebook in these green boxes are kind of what we actually care about in this data pipeline. And these are the data assets. So if you'll remember from earlier, a data asset can be any deliverable from a data pipeline. For example, in this case, we've got tables and we've got a Jupyter Notebook. It doesn't necessarily have to be what's happening at the very end of your data pipeline. Here, we're producing data assets at every step in our data pipeline. So now that we've kind of uncovered these assets that are in this pipeline, let's try kind of constructing the same pipeline, but with our focus on the data assets rather than on the tasks. So the first thing we're kind of need to do is figure out like what objects we'll be modeling in the pipeline. So let's start by just like focusing on our legend. So we'll need a way to represent our external source data, which in this case is the flowers database. And we'll need a way to represent the data assets we'll be creating in our pipeline. And the connections or edges in our pipeline that will connect assets, and it'll connect assets that have data dependencies. And this means that the asset at the end of the edge requires data from the asset at the beginning of the edge. And finally, it'll still be useful to understand how each asset is created. So we'll also document the operation required to create the asset along the edge connecting the assets. So let's start by just looking at our iris dataset and analysis first. So we'll start by fetching the raw iris data from the flowers database, and then we'll transform the data using dbt to create our final iris dataset. And then that data is going to get loaded into our Jupyter Notebook and analyzed. And that will create an executed notebook file that we can share. So adding additional data assets to our pipeline looks really similar to this. We can just add new assets for each data set and define how to create those assets. So overall, this pipeline looks larger, but it's actually doing the exact same thing as the task-focused data pipeline. This one's just like a lot more descriptive and aware of the data that it's processing. We can look at this and at a glance, we know exactly what data is available to work with and how those data sets relate to each other. So before we move on, let's just do like a quick visual comparison of these two data pipelines we've designed. So there's like a lot going on this slide, but the main point is to demonstrate that when we model our data pipeline focused on the tasks we want to execute, we get a data pipeline that looks dramatically different from one where we focus on the assets the pipeline should produce. And there are some situations where a task-focused data pipeline is the correct approach, but at Dexter, we tend to believe that the majority of data pipelines should be asset-focused. Again, kind of the point of a data pipeline is to produce data assets that you use at your organization. So it kind of makes sense that it would be helpful to have those data assets be the primary thing you model when you think about your data pipelines. And by modeling your data pipeline with tasks, you actually kind of end up increasing your cognitive burden because you have to sort of understand what each task is doing in order to know what data assets exist. And those are things that are like really easy to forget, especially like over time. And that means that every time you want to do some new analysis, you may have to relearn what the data pipeline does, and that increases the amount of time you have to spend kind of getting your job done. Conversely, when you have your data pipeline modeled with assets as the primary object, you get kind of immediate insight into all of the data you have available, and it can be much easier to figure out like where your new task fits into this pipeline. So how does Dagster fit into all of this? So Dagster provides your framework to build and execute asset-focused data pipelines. And Dagster also has support for task-focused data pipelines, since, like I mentioned, there are cases where that kind of makes the most sense. But again, we think most data pipelines should focus on assets, so that's what we're going to be doing today. So using Dagster's APIs, you can create these graphs of assets that span across the different technologies in your data platform. And Dagster allows you to link these tools together into a cohesive workflow. And you can see how the assets generated by your ingestion tool are consumed by your data transformation tool. And you can launch runs from Dagster that update all of these assets in the correct order. And Dagster also helps you reveal the assets that are already a part of your data tools. So for example, when you load a DBT project into Dagster, rather than a single DBT task, each model becomes an asset, and you can see the dependencies between the models. So in the workshop today, we'll be writing a data pipeline that will result in a Jupyter Notebook. So let's go over some of the main Dagster concepts we'll be working with to build our data pipeline. And the most important one is the software-defined asset. So in Dagster, a software-defined asset is a software declaration of a data asset you expect to exist. So it's a way to write in software that you expect a data asset like an ML model or a table in a database or a Jupyter Notebook to exist. So in software, this is a combination of three things: the name of the asset, the names of any upstream assets it depends on, and the function for updating the assets. So after you've written some assets, you can review the resulting asset graph in Dagit, which is Dagster's UI. And from there, you can materialize the assets. And this executes the decorated Python functions and stores the data to a persistent location. So let's talk through what will happen if we materialize the two assets we have here. So first, Dagster is going to execute the raw iris dataset asset. And it'll do this because it sees that it doesn't have any upstream dependencies, so it can be executed. So it's going to execute this decorated Python function and store the result in a persistent location. And by default, that will be to your local file system, but you can also save outputs to S3, GCS, Snowflake, and other locations. So then Dagster is going to execute the iris data function, and there's a little magic going on here. So Dagster knows that the raw iris data parameter passed into iris data corresponds to the output of the raw iris data asset. So Dagster is going to load the raw iris data asset from storage and provide it as input to the iris data function. And then we execute this function and add these column names and return the result. So again, Dagster will store that to a persistent location. And the persistent location is actually important here. So the next time we want to materialize these two assets, the new return values will be written to the same location as the previous values. And this means that if we want to manually look at the most recent data, we know the exact location to look at. There's no more looking at a bucket of data files and like wondering which one has the most recent data. And the persistent storage location also allows us to materialize an asset without necessarily materializing the upstream assets. So if we wanted to rematerialize this iris data asset, we can just tell Dagster to materialize this one asset, and it'll fetch the data we stored for the raw iris data from the last time that asset was materialized. So Dagster also has built-in support for working with notebooks with the DagsterMill library. And DagsterMill is just a thin wrapper around PaperMill that allows Jupyter notebooks to be directly executed from Dagster pipelines. So instead of kind of copying the development work you do in a Jupyter notebook into a Python function, Dagster can just run the Jupyter notebook as part of your data pipeline. And you don't need to translate that notebook into some other format and potentially like lose readability. And you can also connect your notebooks to assets that are already in your data pipeline. And this helps remove the need to replicate data loading logic like within your notebook. And you'll also get some handy like built-in metadata and lineage tracking and the ability to view your notebooks in Dagit without needing to start a Jupyter kernel. So let's move on to the workshop portion of this. So like I mentioned, we're going to be productionizing a notebook that analyzes the iris data set. And more specifically, we're going to be writing like a slimmed down version of the data pipeline we just designed. So we'll create two assets, one for the iris data set and another for the Jupyter notebook. And the Jupyter notebook will use the iris data set asset as its input data. And we'll be working directly with the canonical iris data set, so we don't need to do any data transformation step in our pipeline. And additionally, we won't be using any external tools to fetch the data set. We'll just be using Dexter and the DagsterMill library to execute our Jupyter notebook. And then at the end of the workshop, we're going to also start executing a Noteable notebook, and we'll explore some of the features there as well. So for each step in the workshop, basically, I'll talk through what we're going to do. I will demo it on my computer, and then I'll go back to a slide that kind of lists the task to complete. We'll wait a couple of minutes for each step so that everyone has enough time to complete it. And if you run into any issues, you can just put it in the Zoom chat, and myself or Matt will try and help you out. I think since we're in Zoom, what might be kind of helpful is like once you're done with the task, if you could use like a little like raise hand feature or one of the reactions, just so I can kind of get a good idea of like who's done so we can move on. Cool. And then during the first step of the workshop, we'll download the code we'll be using, and that will also have a README in it that contains all of the steps for the workshop. And you'll also get a fully completed version of the project as well. So if you're the kind of person who would like to just like listen along to this kind of thing, but you still kind of want to see the final version of the code and maybe play around with it, you'll also be able to do that. So the first thing we'll need to do is actually just get our environment set up. So I'm going to be using a tool called Gitpod that creates a fresh Python environment that I can use directly in my browser. So if you're up to try that out, I would definitely recommend giving it a try. I'll kind of help us all be using the same setup. And that'll make any issues we may run into easier to fix, since we'll all be kind of working from a consistent place. But if you'd rather use like a different virtual environment tool, definitely feel free to use that. Just make sure you're using a Python version greater than 3.6. So when you sign into Gitpod, eventually you'll be sort of dropped into something that looks a lot like a VS Code editor like this. So once you're here, give me like a little React, and then we can move on. Cool. Okay, looks like we're looking good. So the next thing we'll need to do is like install the example code we'll be working with and all the required dependencies. So I have all of these commands here in this text file if you want to start executing them along with me, but I'll also go back to that slide once I'm done. So we'll just start by just like upgrading pip just to make sure everything, I don't know, goes a little bit more smoothly. And we'll need to first install Dagster. And once we've installed Dexter, we'll actually have access to a CLI tool we have that will allow you to like download custom and like fully supported Dagster example projects. So that's what we're going to be doing here. Let me actually make this a little bigger so you can see the full command. We're going to be downloading an example called tutorial notebook assets, and then we can do that. Might be helpful if I throw these in the chat. Yeah, let me do that. Great, okay. So once we have the example code downloaded, we can just move into this new folder that's been created, and then there's a setup.py file in there that we can use to install all of the required dependencies. I'm doing this pip install. I don't know, it takes like 30 seconds or so. So I'll wait here, you guys can get started, and then we can move on. All right, great. So let's just take a minute. I'm now kind of walk you through sort of what's in this project you downloaded, and we can pull up kind of the files that we'll be working with. So let me make this a little bigger so you can see the file names a little easier. So in this Dagster Notable Demo folder, we have kind of two subfolders. There's tutorial finished that contains a fully completed version of the workshop today. So you can use that to like get a sneak peek into what we'll be doing or just kind of see the final version. But where we'll be working is in this tutorial template folder. So in here, we've got a couple other subfolders. The ones that are important are in the notebook subfolder, which is where our Jupyter notebook that does the analysis of our iris data set is. We'll go through this in just a minute, but you can open that up in your text editor. You should see this comment at the top saying that we're filling it out as part of the PyData workshop, and that if you see that comment there, you know you're in the right folder. If you don't see it, you might be in the finished version of the tutorial. The other file of importance is in the assets folder, and it's this init file here. Again, if you open that up, you should see this comment at the top. And this is where we're going to be writing all of the assets that we'll be making as part of our data pipeline today. Most of what we'll actually be doing is like uncommenting code blocks to help kind of keep this workshop mostly bug-free. But I'll be going through exactly what we're doing at every step so that you kind of understand like what all of the code is doing. So I recommend just having both of these files like open in your text editor so that they're easy to get to. So let's go back to the notebook file, and we can just kind of quickly look at what's going on in this file and get an idea of what our notebook is doing. So the first thing we do is download the iris data set from the internet, and we're going to do some column renaming so that way we can analyze it like more efficiently later. You can ignore this cell here. We'll get to it later in the workshop. But then what we're going to do is actually, let me start running this, is get into some sort of descriptive analysis of our data. So we'll just start kind of exploring our data set, understanding what's there, getting an idea of kind of like what the data looks like. So I didn't start at the actual top cell. Okay, now it should work. All right, here we go. So we've got kind of looking at our data. We're going to make this plot here that gives us an idea of like what our data looks like and how the different axes of the data kind of compare to each other. And then we'll get into our actual k-means analysis. So we'll run our clustering algorithm, and then we're going to do some more plotting so that we can understand like how our clustering did. So if we scroll down to the very bottom, we'll see a plot with our results, and we can see that like one of our species of iris data is very easily, I don't know, like distinguishable from the other two, but the other two are still a little mixed up, which means we might need to do some more like complicated analysis to separate them. So that's a tour of our Jupyter notebook. So let's move on to actually like writing some code and getting this working with Dagster. So we're going to go back to the init file. Again, you should see this comment at the top, and that way you know you're in the correct spot. And so the first thing we're going to do is actually scroll down a little bit, and we're going to uncomment this code block under to do one. And when you do that, this one line is still going to stay commented, and that is fine. We're going to get to it in a minute. So let's walk through kind of what this code is doing. So we want to start by making an asset for the Jupyter notebook we just looked at. And in the kind of Dagster API we went over in the presentation, doing that might look something like this. We would have our asset decorator, the name of our asset, the code to execute our notebook, and then maybe we would return our executed notebook. But you'll notice I just have this comment here, code to execute the notebook. And that's because it's actually quite complex to execute a notebook. And so the Dagster library kind of helps abstract away that complexity, and it just gives you a helper function that will just return this whole asset for you. So instead of having to write this out yourself, you just get to call this helper function, and it does all this work for you. So we don't need that. So let's look at kind of what we're providing to the helper function. So we have our define Dagster asset function. We give it the name we want our asset to have, and then we give it the path to our notebook file. And then the last thing we're doing in this case is giving it a group name. This is sort of an optional parameter we can provide, and it just kind of helps with organization in Dagit. So once we call this function, it's going to create that asset that will execute the notebook, and it'll return it back to us. So I will just like, again, wait here for like a minute or so, and then we will move on. So now we can move on to actually materializing our asset in Dagit. So back in Gitpod, we need to actually start running Dagit, which we'll do in the terminal. The command is just Dagit. If you're in Gitpod, this little like alert is going to pop up asking you if you want to open port 3000 in your browser. You just want to click open browser. If you're running in a virtual environment, it should print out a link to localhost 3000, and you can just open that up in your browser and you'll land here. So Dagit is Dagster's UI, and now that we are here, we'll just kind of do a really quick tour before we get to materializing our asset. So this first page we're on is sort of like your home page timeline view, and it'll give you like an overview of all of the like kind of recently run data pipelines or assets that Dagster is executing. We haven't run anything yet, so this is blank. So we'll go up here to this left hamburger menu in the top, and we'll see sort of our two different like repositories or Dagster projects that we're running. So we have one for the finished version of the project, and then we have our template project, which is where we're working right now. So let's open up that one. We'll have, you'll see this like ping Notable job. This is here to help us like test our connection to Notable later in the workshop if we need it. And then here in this asset groups, you'll see a template tutorial asset group. And that is from the group name we added to our asset earlier. So let's click on this asset group and we can see our notebook asset right here. So we can click on this asset and this right side panel will pop open with some more information about the asset. We got our description. We can click this View Source Notebook button and it'll open up a preview of our notebook and we can see the contents. And then if we close this, we can click the Materialize button and this will actually like execute our notebook. So let's go ahead and click that. And then this view window is going to pop up and you can click this view button to watch the asset materialize. If you kind of miss this button at first, you can come back down here and click this little hash that appears on the asset itself. So we'll go here. I took a little bit of time, so I missed watching it actually execute, but we can see that our notebook has executed successfully. And then if we go back to our sort of main asset page and click on this, we'll have some additional metadata about the asset, and we can actually click this to see the executed version of the notebook. So I will give you guys a minute to kind of go through that process yourself, and then we can move on to kind of the next steps in making our data pipeline. All right, so we've executed our notebook, but if we go back to our notebook file, we'll see that, you know, the logic to kind of fetch our data is still in this notebook. And that means that every time we execute this notebook, we're refetching our data set. And that may be like a really costly operation, and we may not want to do that every time we execute the notebook. And so we're going to, like, the next thing we're going to do is actually like factor out this data fetching into its own asset. And we want to do that for a couple of reasons. Like the first one, like I mentioned, of not necessarily having to refetch the data every time we execute this notebook. It'll also help us if we ever want to add like a second notebook, also analyzing the iris data set. So instead of having to copy the data loading logic into that notebook and potentially worry about them getting out of sync, and maybe one notebook is analyzing a slightly different data set than the other, we can instead just have one asset that has the iris data set, and both notebooks will use that asset. So we're going to go back to our init file in the asset folder, and we will go ahead and uncomment the code block under to do 2. So this asset looks a lot more like the ones we went over kind of in the presentation portion. You know, we have our asset decorator, we give our asset the name, and then we just tell it what we want it to do. Again, we have this group name here just to help with organization. So we have this iris dataset asset now, but we still haven't told our notebook to use it. So to do that, we'll actually just scroll down a little bit and we'll uncomment this line that has the to do 3 comment in it. So we'll uncomment this. So this will help tell Dagster that we should be using the iris dataset asset in our notebook. And we do this by specifying kind of this dictionary or a parameter called ins. So if you will recall from our notebook, we are storing the fetched iris dataset in a variable called iris. So in our dictionary here, we're going to say that we want the variable iris to be provided by the asset iris dataset. So we can go ahead and do those 2 things, and then we will do like one more change in our notebook file, and then we'll be ready to materialize these assets again. So again, wait here for like a minute or 2. Cool, that was easy. We've got our iris data set being fed into our notebook asset, but we need to do one final small change in our notebook so that we know not to actually execute this code. So we could just kind of delete this and that would be fine. But then if we maybe wanted to standalone execute this notebook, we might run into issues and we'd have to copy this back in. It could be frustrating. So instead, what we can do is kind of take advantage of how PaperMill works and move this chunk of code into a cell tagged with the tag parameters. So behind the scenes, when PaperMill is executing your notebook, what it does is it finds a cell that has the tag parameters in it, and then it's actually going to overwrite that cell with some cell content you provide. And when you execute a notebook with Dagster, we override the cell with some code that's going to be able to fetch the content of the asset that you specified as input to your notebook. So if we just cut and paste this block of code into the cell that says it's been tagged with parameters, instead of executing this code, it'll actually get overwritten and we'll be pulling in the value from the iris data asset. So the reason we're cutting and pasting code here is that in Gitpod, there's not really a good way to add parameters or add tags to Jupyter Notebook cells. So in the real world, if you were doing this, you would be either in your Jupyter kernel or in your VS Code editor, and you would just add the parameters tag to the cell where this iris data set fetching is happening. But instead, we've provided a cell that is already tagged with parameters for you, and you just need to move the code into that cell. So, right, so you can't see the parameters tag in this cell, but I promise you it is there. And when we execute the notebook, it's in the metadata and it'll be found, but you just can't see it in Gitpod. So we'll wait here. Again, you just need to cut the this block of code and move it into the cell that's been tagged with parameters. Okay, so now we can go back to Dagit and we can click this reload definitions button. And this is going to just basically look at the new assets we've created and pull them in so we can see them in Dagit. So we should see our iris data set asset now, and then that is upstream of our Jupyter Notebook. So we're going to materialize these assets, but real quickly, just to fully go over what's going on. Again, what's going to happen is Dagster is going to execute this iris data set asset. It's going to fetch that data and then store it in local storage. And then it's going to execute this notebook asset. And because we have this new parameter cell, and we've set up the kind of input mapping of our upstream asset to this variable. It's going to inject the content of our iris data asset as the iris parameter, and then we'll be doing our analysis on that asset. So we'll click the Materialize All button. And then again, we can click this View button to kind of watch this all execute. It's a little crowded on my screen because it's kind of tiny, but you can kind of watch these assets execute up here. Okay, great. So that's done. So now we can go back to our main Dagster page. And again, we can click on this View Notebook button to see our executed notebook. And you can see that we've injected the cell that's got some kind of funky code going on that's pulling in the asset that we materialized before this one. So give everyone just a minute to do that, and then we can move on. So we sort of completed the Dexter and Jupyter portion of this, and we're actually going to kind of move on to start looking at Notable. So we're going to go through kind of a very similar process as what we just did, but with a Notable notebook. So the first thing we actually need to do is make a Notable account. So if you can go to notable.io and make a free account, and then we can go ahead and start creating a notebook there, and then we'll execute that in Dexter. But first thing to do is we can just make an account and then we'll go through the rest of the setup after that. Once you're in Notable, you'll see kind of a page that looks like this. You'll be in like your space. And then once you're there, you're good. And then we will move on.
And the sign up button looks a little different than the screenshot there, but it's the big button that says sign up on the front page.
Oh, awesome. Yeah, these slides are what, a month old now. So.
Or they get started for free, I think is the new label.
Okay, so the next thing we'll need to do is actually upload the notebook we were just working with to Notable. So if you're in Gitpod, you can download the notebook we've been working with over in the left sidebar. You can right click the name of the notebook, and then there's this download button here. And then that will download the notebook. And if you're working locally in your own virtual environment, you should just have it on your computer. So then we can go back to Notable. You should have a project, probably called something like My First Project or some other kind of default name that's created when you make your account. So you can click into that and then click this upload button. And then we can drop our downloaded notebook into this little upload window, and then it should be uploaded. And then we can just open that up and see our the same notebook just in the Notable UI. So
could you
we'll go ahead
show
and
the download real quick?
Oh yeah, for
from
sure.
Gitpod.
In Gitpod, yeah. So it's in the like kind of file navigation, the file in there, that's the Jupyter notebook we've been working with, and then you just right click, and then there's the download here. So the last thing we need to do is actually get an API token from Notable. So again, to do that, from within Notable, you can click on your profile and go to settings. And then on the left side, there will be this API token section, and you can generate a new API token and copy the value. And then once you have that value copied, we want to go back to your terminal. If you're still running Dagit, you can just Control-C to shut Dagit down. And then you want to create an environment variable to store your Notable token. So it has to be the name, all caps, Notable _ token equals, and then you'll put in the API key you copied. So, and then once you've done that, you can just like restart Dagit with the same command as before.
And these tokens are just basically like any other GitHub token or any other service token you'd have. So you can delete them and make new ones. They're sort of a way for machine to act as you on behalf in the Notable ecosystem while that token is valid. And the default there, if you see, they set up for 1-year tokens, so you don't have to worry about expiring in the short term. You can just kind of play with it. We got 1 thumbs up. Two thumbs up. Close if other people probably follow. Okay, I think we got everyone.
Cool. Okay. Yeah, I had to go through and set up my token as well. So thanks for keeping an eye on that. Okay, great. So now we can actually make an asset for our new Notable notebook. So back in Gitpod, back in this init file where we've been making all of our other assets, you can scroll down to the very bottom and there's this to-do 5. So we can uncomment this code block. And this is doing pretty much exactly the same thing as our defined Dagster mill asset, but instead we're defining a Notable Dagster asset. Again, we're giving a name to the asset, specifying kind of our input mappings, and then giving it the group name. The main difference is that instead of a notebook file path, we need to give it a notebook ID. And we'll go over getting that notebook ID in the next steps. You can just leave it like this for right now. So the last thing we need to do for running this asset is actually get that notebook ID, and we can do that by going back to the notebook we uploaded and just getting it from the URL. So in Noteable, just open up the notebook we uploaded, and then in the very top, you should have sort of this ID kind of in the middle of the URL, and you can just copy that and then go back over to where your asset is defined, and we will just replace the value of this notebook ID variable with the value we copied. All right, so now we can be back in Gitpod. I did not restart Dagit. So if you also did not restart Dagit, you can take this time to do that. If you're in Gitpod, I think it'll like reopen that little like window if you want to open it. I'm not 100% sure how Gitpod works, but it might be starting like a new like port forwarding thing each time. So we're back in Dagit. We can go back to our asset group and we'll see our new notable asset. If you restarted Dagit before we uncommented that notable asset, you may need to click this reload definitions button, and then you should see it appear. So we have our notable notebook. It's going to be using the iris data set as input. So we can execute this. We can hold down on the shift key and click the iris data set and the notable notebook, and this will materialize both of those assets together. So we'll go ahead and click materialize selected, click the view button, and then we can watch this happen. And what's kind of nice when you're using Noteable is that once the notebook starts executing, you'll actually get a link to the live notebook. So we can just wait a second, and then that link should appear here in the logs, and we can click on that, and we can actually watch our notebook like execute in real time. So we'll just take a second for the kernel to start, and then we can just like watch our notebook execute.
And the notebook that's running in this type of parameters run, it's being executed. By the way, I think this is the parameterized in the input rather than the
yeah.
Oh, okay, got it. So this notebook here is, it's live running, and you can have multiple people sitting and watching at the same time. You can have multiple editors on the same time if you want to pair debugging something that comes up. It's an ephemeral copy of that original notebook you had that's for this particular Dagster materialization.
Right. Yeah, so I mean, if you wanted to like, I don't know, I guess like test that out, you could go back to Noteable and open up the notebook you uploaded, and you'll see like that's just sitting here, not being executed, whereas like this copy of the notebook is being executed. Okay, there we go. So it's run successfully. We can go back to Dagit. We can click on it, and in the right sidebar, we'll have this link to Noteable that shows kind of that'll like reopen that ephemeral notebook and show you like the last executed version. So we can wait there for a minute just to finish like executing all your different notebooks, and then we'll jump into like actually doing like some live debugging and sort of like what it looks like if your notebook kind of fails halfway through and how you would deal with that. All right, so yeah, into live debugging. So in order to actually have something to debug, we need to like introduce an error into our notebook. So we can go back to the notebook we uploaded. You shouldn't like, I don't know, this is the one that was executed. We can exit out of that and go back to kind of the like source version of our notebook that we originally uploaded to Noteable. And I'm just going to scroll down a couple of cells, maybe after this iris.head cell, I'll add a new cell, and I'm just going to raise an exception. Obviously, this will be a very easy bug to fix, but you can kind of like imagine what this process would be like with like a more like challenging bug that you may have to actually like dig into your data to figure out. Well, let's just throw an exception in here, and then I will. Then we can like wait for a second, get everyone with a notebook that will fail, and then we'll go through and materialize this notebook and then debug it. Great, so we're going to go back to Dagit. We can just click on our notebook and materialize it. We won't need to rematerialize this iris data set because we already have that data. So we'll click on our notebook, click materialize selected, And then we can click on the view button. And what we should see is this notebook fail. And then we can go off of that. So we have this notebook link here. Again, we're going to kind of wait for the notebook to fail. And then we can click on this link and start trying to debug it. You can sort of like imagine a situation where, maybe you have this notebook running on a schedule, so you're not like watching it execute every time, and you see that like the last like scheduled execution of the notebook failed. You can go back into the logs, find this link, and then get into the live notebook and start debugging.
And by default, that live notebook will stay around for 90 minutes. So after 90 minutes, it'll shut down the context and clean up. But for now, from this point on, we have 90 minutes to go jump into the live session. Otherwise, you'll get the not live copy of what happened.
Yeah. Cool. So we also get some logs in Dagit. Obviously, our bug here, very simple. We could pretty quickly figure out what's wrong just based off of these logs. But again, if our bug were a lot more nefarious than that, maybe we can click on our live notebook, and we will be like dropped into this live notebook here. We can maybe delete this, and we can see that we can still do we can still investigate our data. Like everything is like already loaded into memory. So if there were issues with our data, we could start like popping in here and trying to figure out what's going on. So we found our bug, we had that exception in there and said, we can just like change that to something else. We can delete it, whatever. And then if you want, you can just start executing the remainder of the cells in your notebook, maybe just to like make sure that things continue as you expected.
And there's a run all from the menu at the top when you want to go to it, if you want to run from all below.
Oh.
Oops.
I clicked the wrong thing.
That's okay.
Right.
It's a live session. You can just go right back to it. You go back. Don't worry about it. I tripped you up by throwing in another thing.
Run all. There it is. Great. Okay. Cool. And then it should completely run through. And yeah, my fix of changing the exception to the current was saved, and we're all set from there. So going through kind of that process of doing that little like live debugging exercise is kind of the last step in the workshop. So we can stop here, do any do like a little like Q&A if you guys have any questions, and then we'll be done.